Hello, we are presenting on our project Enhancing Harbour Security using XSAT Imagery and AIS Messages. This project is done by me, Bryan Lee, and my teammate Go Tzu Sing. XSAT and AIS, what are these? XSAT is Singapore's first observation satellite launched in 2011. It was designed by CREST and its images are received at CRISP. Automatic Identification System AIS is a universal system that ships are required to use to broadcast messages for safety and regulatory purposes. We use C++ programming software and WX widgets to produce a code that correlates the satellite image and AIS data, plotting the data as points onto the satellite image, thus producing a map showing the routes of the ships. Our aim is to pinpoint ships not correlating with the map, thus allowing further investigation, preventing unauthorized ships from approaching Singapore's waters. Our approach is separated into 4 main parts. AIS messages were sorted into one single array using WX tokenizer, which breaks up the data string, thus separating information. It was then converted to an integer indicating the ship's ID, time, speed, longitude, and latitude. It was then sorted according to ship ID using a loop. Messages from the same ship were sorted into a single vector until the program encounters another ship ID, where it will create another specific vector for that particular ship. This continues until all messages have been sorted. A rendering buffer is an image with an accessible data buffer, thus more efficient to work on directly. It was created using WX bitmap and memory DC. Width and height was set to that of the XSAT image, while the background was set to black using WX pen and brush, thus easier for overlay. Information from AIS messages were converted to X and Y screen coordinates for the computer to plot these points onto the overlay. This was done by proportionating width and height values with longitude and latitude. Points representing individual AIS messages were created, and subsequent points were joined up, producing the route of the ship. This is the overlay, red lines representing the tracks of vessels near the southern coastal regions of Singapore.
Using GIMP, the AIS overlay was stacked onto the satellite image of Singapore as 2 layers, and the black background was filtered and then aligned, leaving behind lines which depict the track of the ships. This shows the edited superimposed image. Using the superimposed image, we can clearly identify the ships that are not on the lines of the track. Hence, this can be reported to the relevant authorities for further investigations. Due to off-course surveys, the satellite image taken was not flat, and this inconsistency causes the line plotted to be distorted and misaligned. Hence, this can be solved using GIMP. There were linear lines due to inconsistency of the result, since the algorithm would draw the subsequent point regardless of its rationality. To minimize this problem, a loop was created such that the algorithm will only plot the next point. It is 50 pixels in length next to the original point. And this is calculated using Pythagoras theorem. As you can see, our algorithm worked well. One relevant application would be port authorities can make use of the algorithms to detect and track ships that do not broadcast AIS messages, hence serve as an advanced detection and security system for Singapore. Our algorithms can be merged with other algorithms so that it can automatically detect ships that do not broadcast the AIS message. Also, we can go around Singapore to collect GPS longitude and latitude values so that we can scale the image to correct proportion for optimum superimposition. In conclusion, we make use of C++ programming to create a superimposed image of XSAT showing the routes of ships using the AIS messages so that we can identify ships that do not report. Thank you.